Imagine you're throwing a massive party at your house. People come, they eat, they leave cups and plates everywhere. Now, you could chase after every single guest, cleaning up their mess the moment they set something down. Exhausting, right? Or you could let the mess pile up a bit, then sweep through and clean everything at once. That's essentially what garbage collection is. But for your computer's memory. Here's the thing. When you create objects in languages like Java, Python, or JavaScript, you're allocating memory. But unlike C or C++, where you have to manually free that memory like a responsible adult, garbage-collected languages say, "Relax, we got this." They automatically detect when objects are no longer being used and reclaim that memory for you. So how does it actually know what to delete? The garbage collector is basically a detective. It starts at your program's roots, things like global variables, active function calls, and anything currently in use. Then it follows every reference, every pointer, marking everything it can reach. Think of it like playing a massive game of Connect. Anything that doesn't get marked, that's garbage. That's memory your program forgot about and will never use again. The collector sweeps in and frees it up. But here's where it gets interesting. Garbage collection isn't free. When the collector runs, it often pauses your entire program. We're talking milliseconds, sometimes longer. For a web app, you might not notice. For a high-frequency trading system or a video game, that pause could be catastrophic. This is why some developers still prefer manual memory management. They want that level of control. Different languages use different strategies to. Java has generational collection, assuming most objects die young, so it checks newer objects more frequently. Python uses reference counting, keeping track of how many pointers reference each object. JavaScript engines like V8 use a combination of techniques to minimize those dreaded pause times. The beauty of garbage collection is that it eliminates entire categories of bugs. No more memory leaks from forgetting to free something. No more double-free errors that crash your program. No more use-after-free vulnerabilities that hackers love to exploit. You trade a bit of performance and control for safety and convenience. And for most applications, that's absolutely worth it. The garbage collector is your silent cleanup crew, working behind the scenes so you can focus on building amazing things instead of babysitting memory.